Hi everyone, welcome back to another day of notes. Today we're going to be doing domain and range. So first we're going to go ahead and talk about the vocab. So independent variable is a variable that will happen on its own. So usually there's going to be two variables that we're talking about. One depends on the other. One's going to happen no matter what, like time, age, those kind of things don't change just because something else changes. Those are our independent variables. Dependent variable is the one that depends on another variable. So I can't really determine someone's weight unless I know like their age and stuff like that, or their height and stuff. So that is a dependent variable. Domain is the x values of a relation. So when we talk about relations and all the ordered pairs and stuff like that, the x values make up the domain. The range are the y values of that relation. Now, when we are writing domain and range, it has to be written the same way, and it has three main requirements. The first one is that all the numbers are written in order from least to greatest. Okay? The second one is that we don't have any repeating numbers. So even if all the x's are -5, we're not going to write -5 however many times it was used. We're just going to write -5. Because it's not asking how many times they were used, just asking what was used. Okay? And finally, the last thing is they need to be written within braces. Braces are these curly parentheses. This is what they look like. I'm not going to judge you based on how perfect they look. So as long as they don't look like parentheses, that's really all that matters. If you kind of look at it from the side, it looks like a little whale tail. So you could try writing it like that. Now, we talked about different representations the other day in class. We talked about mapping diagrams, ordered pairs, tables, graphs, and we can determine the range and the domain from all four of these representations. On a mapping diagram, our x values are all within that first bubble, so that's where we can find our domain. The second bubble tells us all the y values, which will give us our range. In an ordered pair, the first number of the ordered pair is your x value, so all the first numbers will give you your domain. And the second number are your y values, so all the second numbers of the ordered pairs will give you your range. In a table, sometimes tables are labeled with x and y. Sometimes they're labeled with other variables, and sometimes they're labeled with real-world examples. Okay? But basically, the x, or the independent variable, will give you your domain values, and your y's, or your dependent variables, will give you your range. Okay? And then on a graph, very similar to ordered pairs, the x value of the point will be your domain. I can't remember where I put this. Oh yeah. The x values used for the points give you your domain. And then the y values used for the points will give you your range. Okay? If you need to, pause the video so you can write this stuff down. Alright? A function. Did we already talk about functions? Oh, it's just a reminder. Okay, reminder, a function is a relation in which every x value is paired with only one y value. We already talked about this. So now we're going to go ahead and find the domain and range for these different representations. And then just for kicks, we're going to tell if it's a function or not. Okay? Just so you're aware, this is very similar to how it will look on the test and a quiz. Okay? Write the domain and range in the following mapping diagram and determine if it's a function. So, for domain, I'm going to look at these x values. Okay? So, to write them out, I'm literally just going to write them in order from least to greatest, with commas in between. So 0, 1, 2, 3. None of them are repeating. None of them have extra arrows coming out, so I just go ahead and write them as they are. And I'm going to put braces around. So notice that I have commas in between and braces around. It's in order from least to greatest. There's no repeating numbers, and I have braces. For range, you look at the y bubble. You write all those numbers, which here it's only 1, but you would write them in order from least to greatest, don't have any repeating numbers. Just write it once and then put it in braces. So that is my range. Now, is this a function? Yes or no? Well, if I look at it, all my x's only have one arrow coming out, so that means they're only matched with one y. So yes, it is a function. You guys go ahead and try this one on your own. Okay, example 2, now we have a set of ordered pairs, so we're going to determine the domain and range, and is it a function or not. So for domain, I'm looking at the x values. So I'm going to go through and underline all of the x values in blue so I know what I'm talking about. So I've got -1, 0, 1, where's my, nope, that one, 1 and 2. So they're already in order from least to greatest, which is great. So I'm just going to write them down, put commas in between, and braces around. The range are the y values, so I'm going to underline those in green. You guys can use boxes or circles or different colors if you want to. I just find it helpful to know what I'm talking about. So my range is actually 4, 5, 6, and -7. I need to put it in order from least to greatest. 4, 5, 6 are in order from least to greatest. But -7 is smaller than -4, so that should go in the front. So when I write it, -7's first, then 4, 5, and 6, commas in between, braces around. Now I can answer, is it a function or not? Well, all these blues none of them are repeating, so yes, it's a function. You guys try this one on your own. All right, example 3, find the domain and range from the table and figure out if it's a function. So the table here doesn't give me x and y. So I kind of need to think, well, I have time and distance. Time is going to happen no matter what, so that is actually my independent variable. Like, time doesn't change based on how far I go. Okay? Time doesn't slow down because you're slower on the racetrack. Time doesn't speed up because you're faster. Okay? So time is independent. Distance, how far you go, kind of depends on how much time you have to go there. So your distance is your dependent variable. Well, independent is my x values, and dependent is my y values. So these are all my x's, and these are my y's. So domain, I'm looking at the x's, 1, 2, 3, 4, 5, 6, and 7. They're already in order, so I go ahead and write them down. Commas in between, braces around. No repeats. Distance, 10, 20, 30, 40, 50, 60, 70. Those are already in order, so I write those down. Commas in between, braces around, and no repeats. Now, is it a function? Yes, because none of the x's repeat. Okay? You guys try this one on your own. I was nice to you, and I gave you an x and a y, so you don't have to figure that part out. All right. Finally, example 4, identify the independent and dependent variables. Okay? Peter coaches soccer clinics and charges $15 per player. T stands for the total amount of money he makes, and P stands for the number of players that sign up. Identify the independent and dependent variable. So sometimes it's actually easier to figure out the dependent variable before you actually figure out the independent. So let's look at the two different kind of variables we have. We have T, that stands for the total amount of money he makes, so his money, and P stands for the number of players. Well, which one depends on the other? Does money depend on how many players are signed up, or does how many players sign up depend on how much money he's going to make? The money is actually being influenced by how many players. As he gets more players, he'll make more money. So the dependent variable is the total amount of money, and the independent is the number of players signed up. How much money he has depends on how many people sign up. Okay? You guys are going to try this last one on your own. Okay? If you have any questions, please write them down, and we can talk about them next class. Other than that, I will see you guys later. Have a great day. Bye.